All right, here we are for section 5.3, standard deviation for chapter 5 of your Foundations Math 20 course. Determine the standard deviation for sets of data and use it to solve problems and make decisions. All right, so here we go. Let's get some information about standard deviation. So one of the things that you'll remember when we did our calculator and we used our stat button, right? It told us our mean, right? So remember this symbol was mean, right? It told us our minimum x, our maximum x, our Q3, our Q1, right? Our med, our median, right? So med on the calculator, was our median, right? Our max x and our min x, and we use both of these to find our range by taking the maximum minus the minimum, right? And we use that to create our frequency tables by dividing by the maximum minus the minimum divided by 10 sections, right? We also had this kind of weird looking character here, right? Well, not really that weird. It's a Greek letter, sigma, right? Now sigma just means add them up. So there will be some number up here, right? And starting at 1, right? And then there's going to be some expression here. I'm going to put x squared in there, right? So what this means is that it wants you to use the numbers starting at 1 and let's say ending at, I don't know, 4 in the expression x squared, and then add them up. So it's going to say, okay, starting with 1, what is 1 squared?
1.
And 2 squared?
4.
And 3 squared?
9.
And 4 squared?
16.
Okay. And what is 1 plus 4 plus 9 plus 16? You got a calculator? Figure it out. 10, 26, 30, isn't it?
Yeah.
30. So, sigma x squared, starting at 1, ending at 4, equals 30, right? So that sigma on your calculator, when you did your variable stats from your stat function, what it's done is it's taken all those numbers that are in your list. Remember, we arranged them in ascending order, right? Smallest to highest, right? Descending order, the other way around, right? What it's done is it take all those numbers and it simply added them up. Give us a total, right? Let's go to this next slide. So, we talked about mean and median and mode, right? There's a whole bunch of other information. There was this symbol, which I'm going to show you right here. Let's jump to this next slide. Right. We talked about deviation, right? How far the data is from the mean. What was the mean? No, that's our middle is our median. What's the mean? Yeah, well, you think of it as average, right? So, when we take our mean, right, or average, right, you add up all those numbers, divide by however many there are, right? So, the deviation is the difference between the data that we have, so some value, let's say x, some number in the set, minus the mean. Right? So let me give you a quick example. We're going to use some of our numbers from yesterday. 7, 7, 8, 9, 10. We'll just use those. All right. So we have 2 7s that repeat. So our mode here is 7. Our median, our middle number, 8. Right? What is the mean? Well, the mean would be 7 plus 7 plus 8 plus 9 plus 10, right? Divided by 5 numbers, right? So let's figure that out. What do you get? 7 plus 7 plus 8 plus 9 plus 10.
41 and then divide by.
Plus 9 plus 10 is 41, and we divide that by 5, and we get 8.2. So our deviation here is 8.2. All right? So,
Isn't that our mean?
what's that?
Isn't that our mean?
Sorry, yes, right, that's our mean. Yeah, sorry, that's our mean. Our mean is 8.2, yes. Our mean equals 8.2, right? So, when we look at deviation, what we're trying to do is go, how far away, and if you look, some of these numbers are above 8, even above 8.2, right? Some of them are below 8.2, right? So, if we take the number 7, for example, minus 8.2, we get negative 1.2. Oh, it's a negative number. Okay, that's right. What this negative means is that it's 1.2 below this mean, this average of 8.2. Let's look at the number 9. Well, the number 9 compared to 8.2 is positive, 9 minus 8.2 is 0.8, right? So it is closer to the mean of 8.2 than 7 is to 8.2. Yeah?
Yeah.
So what we'll find is that with some data, we will have some data where the points, the measurements are close to the average, some that are further away. We may even have some that are like really, really extremely far away. Those are called outliers. So if we looked at a graph, for example, what we might have on a graph is we might have, that wasn't very straight, sorry, all right? We might have on our graph a series of points where, you know, a lot of these points are sort of clustered around this sort of mean area. And then we have a few points that are, you know, a little further away. But then we might have some points like this that are way far out or really, really low. And those are our outliers. Something happened where, I don't know, for some strange reason, remember those batteries at the store, right? The X brand X and brand Y? There was that one battery that it died almost as soon as we took it home from the store. That's probably an outlier, right? It's so far away from the mean. Most of those batteries were pretty close to this central area, right? So they didn't deviate, they didn't move very far away from the mean, right? So that's how we find deviation. So deviation is how far is one point, one data value, away from our mean. Standard deviation is a measure of the dispersion or scatter of data values in relation to the mean. So again, we're looking at our mean. A low standard deviation, so a low standard deviation number, indicates that most of the data is very close to the mean. A high standard deviation indicates that most data values are scattered further from the mean. So we have this really weird looking formula here. And we have this symbol, right? Which we also had in our variable stats calculations on our calculator, right? This is the symbol for standard deviation, right? So, and we'll talk about standard deviation a little bit more when we look at normal distribution, right? So there is a formula for finding standard deviation. It is equal to the square root of, now here we have this sigma again. the sigma, the added up values of each term in our data, minus the mean, and then squared. And it adds up all of those, then it divides it by however many there were. Then it takes the square root of them. So we're going to look at an example of this, and I'll show you why we use our calculator in a moment. All right, so let's jump to the next slide, and then we'll move this up. Okay, good. So we have 2 players on a basketball team. They're recording statistics of the players, right? And at the end of the game, the score is tied, and the best starting guard is fouled out. The coach has to make a substitution. So they want to look at the stats from the last 10 games. Okay? Now, of course, if we look at the last 100 games, we would have a better sense of, a better representation of each player's ability. Right? We're only going to look at 10 games. So, how can we use the coach's data to determine which player to substitute into the game? Right? Well, we can take all of these numbers for each player, and on our calculator put these in L1 and L2 using, from our previous lesson, our variable stats calculator, right? And using our list. Right? So we're going to pause. We're going to put those into the calculator, and then I'll show you what we do with them. So let's go do that now.